3. Creating interactive AR experiences. Adding interactivity to AR objects and scenes. Creating interactive AR experiences involves adding interactivity to AR objects and scenes, enabling users to engage with the virtual content. This can be achieved through various means, such as touch gestures, voice commands, or motion tracking. By implementing animations and physics in AR, objects can move realistically and respond to user actions or the physical environment. Implementing animations and physics in AR. Triggering events and actions based on user interactions enhances the immersive nature of AR experiences. For example, users can activate certain effects or initiate specific actions by tapping on objects or interacting with virtual buttons. These interactions can range from simple interactions like displaying additional information to more complex ones like launching virtual games or simulations. Triggering events and actions based on user interactions. Incorporating sound and audio effects further enriches AR experiences by providing auditory feedback and enhancing the overall immersion. Sound effects can be synchronized with visual elements, creating a more realistic and engaging environment. For example, when a virtual object collides with a physical surface, corresponding sound effects can be triggered to simulate the impact. Incorporating sound and audio effects in AR experiences. By combining interactivity, animations, physics, and sound effects, AR experiences can offer users a captivating and dynamic augmented reality environment, enabling them to interact with virtual objects and scenes in exciting and engaging ways. 4. Scripting and programming in Metaspark Creator. Introduction to scripting in Metaspark Creator. In Metaspark Creator, scripting plays a vital role in creating interactive and dynamic AR experiences. Scripting allows you to go beyond the limitations of visual scripting and gives you the flexibility to implement complex logic and functionality. By writing scripts, you can customize the behavior of objects, control the flow of events, and manipulate data to create immersive augmented reality experiences. Working with visual scripting tools. Metaspark Creator provides a user-friendly visual scripting interface that simplifies the process of creating AR experiences without the need for extensive coding knowledge. With visual scripting tools, you can drag and drop pre-built components and connect them to define the behavior and interactions of objects. These tools make it easier to prototype and iterate on your ideas quickly, allowing you to focus on the creative aspects of AR development. Implementing logic and flow control in AR experiences. Scripting in Metaspark Creator enables you to implement logic and flow control to create interactive AR experiences. By using conditional statements like if-else and loops, you can create dynamic behaviors based on user input or predefined conditions. This allows you to build engaging experiences where objects respond to user actions or change their behavior based on certain triggers. Accessing and manipulating data using variables and functions. Accessing and manipulating data using variables and functions. In Metaspark Creator, you can access and manipulate data using variables and functions in your scripts. Variables serve as containers to store and retrieve data, while functions encapsulate reusable blocks of code that perform specific tasks. By utilizing variables and functions, you can store and retrieve user inputs, track object states, perform calculations, and manipulate data to create dynamic and personalized AR experiences. Overall, scripting in Metaspark Creator empowers you to take full control over the behavior and interactivity of your AR projects. By combining visual scripting with custom scripts, you can create rich and immersive experiences that captivate and engage your audience. 5. Designing user interfaces for AR. Creating user-friendly AR interfaces. User-friendly AR interfaces. Design interfaces that are intuitive and easy to understand, considering the unique characteristics of AR, use clear visual cues, concise instructions, and familiar design patterns to guide users seamlessly through interactions. Building interactive buttons, menus, and UI elements. Interactive buttons, menus, and UI elements create interactive elements that users can easily interact with in the AR environment. Consider the size, placement, and visual feedback of buttons and menus to ensure they are accessible and responsive, allowing users to navigate and manipulate objects efficiently. Incorporating gestures and touch interactions in AR. Incorporating gestures and touch interactions in AR, leverage natural gestures and touch interactions to enhance user engagement. Intuitive gestures such as tapping, swiping, pinching, and rotating can be used to trigger actions, manipulate objects, or navigate through menus and options. Optimizing user experience for different devices and platforms. Optimizing user experience for different devices and platforms. Account for the diverse range of AR devices and platforms available. Adapt the interface design to accommodate varying screen sizes, input methods, and device capabilities to deliver a consistent experience across different devices, such as smartphones, tablets, smart glasses, or headsets. 6. AR tracking and spatial mapping. Understanding AR tracking techniques, marker-based, markerless. AR tracking techniques are crucial for creating immersive augmented reality experiences. Marker-based tracking relies on the recognition of specific markers, such as QR codes or fiducial markers, to anchor virtual objects in the real world. This method provides precise tracking but requires markers to be present in the environment. Implementing object tracking and image recognition in AR. On the other hand, markerless tracking uses computer vision algorithms to track and align virtual objects with the real world without the need for markers. It involves techniques like SLAM, simultaneous localization and mapping, and image recognition. Markerless tracking offers more flexibility but may be less accurate in certain conditions. Spatial mapping and understanding the physical environment. Implementing object tracking and image recognition in AR involves training machine learning models to identify and track specific objects or patterns in real time. This enables virtual objects to interact with and respond to real-world objects, enhancing the overall AR experience. Integrating real-world objects and environments in AR experiences. Spatial mapping is the process of capturing and understanding the physical environment to create a digital representation of it. This involves using depth sensors, cameras, or LiDAR to detect surfaces, objects, and spatial features. By mapping the physical environment, AR applications can accurately place virtual objects, align them with the surroundings, and enable realistic interactions. Integrating real-world objects and environments in AR experiences allows virtual content to seamlessly blend with the physical world. This can be achieved through techniques like occlusion, where virtual objects are hidden behind real objects, and physics-based interactions, enabling virtual objects to interact with the real world's geometry and properties. By integrating real-world elements, our experiences become more immersive and believable.
Thanks for watching. For more information, like, comment, and subscribe our channel.